Hello data nerds! Today we want to talk about the training process inside Stable Diffusion. In the last video we covered the Stable Diffusion algorithm and how your text prompts become images. And I told you also that the magic is coming from the knowledge which is put into the models in the training process. The idea of a diffusion model is that you take an image and add a little bit of noise to it. So you obtain a slightly noisy image. Then you repeat that process about 1,000 times to obtain a fully noisy image. You know for each step the original image or slightly noisy image and its noisier version. Then you train a neural network which gets as input the noisier example and has to predict the denoised version for the image. In doing so for many different steps, the neural network learns to denoise a very noisy image in a repeated manner to obtain the original image. During the training, there also exists an encoder which is the counterpart of the decoder. The autoencoder can be trained to get the best image representation. That's just the image represented in a semantically meaningful way, but with 64 times less pixels. The training of the diffusion model, which is on pixel space, needs to calculate 64 times less than before. An image with existing caption is used for training. Noise gets added to the encoded image in the successive time steps. Text caption gets embedded by the language model. The diffusion model receives a noisy version of the image. And the text embedding that needs to predict the previous time step of the image. Gradient descent is used on the pixel difference between the expected image and the prediction of the diffusion model. Given the sequential number of steps to make an image noisy, or in the inverse process to denoise it, this can be described as a Markov chain, because every time step only depends on the intermediate successor. I think the magic is the overlap composability of concepts which have been learned during the training. All of these models parts are trained on a huge amount of images. Embeddings for the autoencoder and the language model cover most of our human semantic space. This knowledge is saved in the latent space. When finally combining all of this into a prompt, the system tries to integrate all of this knowledge to the most likely image